Hi everyone, welcome back to ChemHelp ASAP. In this video, we are going to talk about density. Now, you may think of density as just a calculation. Density equals mass divided by volume. But did you know that density makes an excellent conversion factor? It is great when you have to convert between mass and volume. So we will be using density as a conversion factor, but I will also show you how to take the units of density and convert them into whatever units you need for a specific problem. So maybe you find a density that's given in grams per milliliter, but you really need to convert that to a density that's kilograms per meters cubed. Well, we are going to do all those problems and more. So let's get started.
Let's read our first problem. The density of 10 is 7.31 grams per milliliter. What is the density if measured in ounces per centimeter cubed? And then they give us a conversion factor. There are 28.35 grams in 1 ounce. What we need to do in this problem is we need to convert grams per milliliter into ounces per centimeter cubed, which means grams needs to be converted into ounces and milliliters need to be converted into centimeters cubed. And again, they gave us a very helpful conversion factor. We're going to start with what we're given. The density of 10 is 7.31 grams per milliliter. Notice how I don't write the units like they gave it in the problem with just the slash here, but I write it as a fraction. This is going to help you make sure you keep track of what's going on in the numerator versus what is going on in the denominator. I am going to start by converting the numerator. I am going to convert grams into ounces. However, if you prefer, you can always start with the denominator and first convert milliliters into centimeters cubed. It does not matter which one you start with the one that you prefer. So I am going to use the conversion factor the problem gave me. Here is my 28.35 grams in 1 ounce. Notice how I set it up so that my grams cancel. And now I am left with ounces, which is what the problem has asked me for in the numerator. However, I'm not finished yet because I still have to convert my denominator. So you may or may not know the conversion factor between milliliters and centimeters cubed, but it is one of the easiest conversion factors. 1 milliliter is equal to 1 centimeter cubed. They are the same. So here is my conversion factor. It's a simple 1 to 1. But again, my units cancel. You can see my milliliters cancel, and now I'm left with centimeters cubed. So just to go back, make sure units that I want to have canceled, and units that I need to have in my answer are still around. So you can see both grams and milliliters have been canceled. That's great. That's what I want. I'm left with ounces in the numerator, which is exactly what I want. And if I look at my last conversion factor, I can see that I still have centimeters cubed, which again is what I want. So let's put this in our calculator. We're going to take 7.31 divided by 28.35, and then if you prefer, you can multiply by 1 as well. My final answer is 0.258 ounces per centimeter cubed. So know that when you are given a density, if you need it in different units, you can feel free to convert these units to whatever you need for your problem. But let's do another problem. This problem reads, a truck has a fuel efficiency of 9.80 mpg, which is miles per gallon. What is the fuel efficiency in kilometers per decimeter cubed? And then again, some conversion factors. There are 1,609.3 meters in 1 mile. And also there are 3,785.4 milliliters in 1 gallon. We are definitely going to string together multiple conversion factors here. So what we're going to have to do is we're going to have to convert miles to kilometers. So we're going from imperial to metric. And then we're going to have to convert gallons to decimeters cubed, which is also imperial to metric. Now, if you need help converting between metric and imperial or imperial to metric, I do have a video on that. You can check out the link in the upper part of your screen right there. But let's get going on this calculation. Starting with what I was given, my 9.80 miles per gallon. Again, notice I write this as a fraction instead of writing it as mpg or even writing it as miles and maybe a slash per gallon. A fraction is going to help you keep track of what's going on and what needs to be canceled. I'm going to first take care of my miles and get that to kilometers, and then I'll come back and worry about my gallons. So I am going to use a conversion factor they gave me here, so I can go from miles to meters. Here is my conversion factor. In 1 mile, there are 1,609.3 meters. My miles cancel, and now I'm left with meters. However, I need to go to kilometers, so I need another conversion factor. There are 1,000 meters in 1 kilometer. So my meters cancel, and now I have converted into kilometers. If this is a conversion factor that you are unfamiliar with, then you might want to go back and review metric to metric conversion factors. These are all based on prefixes. I do have a video on that. You can check out the link above. At this point, I do have kilometers in my numerator, which is what my problem asked for. So my numerator is set. Now I just need to deal with my denominator. So right now I still have gallons. It's just been hanging out there, and I need to go all the way to decimeters cubed. I am first going to use the conversion factor that the problem gives me. So in 1 gallon, there are 3,785.4 milliliters. My gallons cancel, and now I have converted into milliliters. But here's a place where you might feel a little bit stuck, because you're saying, I have got to get to a unit that is cubed in the denominator. And right now, I just have milliliters, which is certainly not a unit that is cubed. So how do you move between a unit of volume that is not a cubic unit and get to a cubic unit? Well, one of the easiest ways to do that is to use the conversion factor that I wrote up here. This is just a really easy conversion factor, and you can see it's going from a non-cubed unit to a cubed unit. Of course, you can always ask Google, and Google can give you the conversion factor from milliliters to decimeters cubed. But again, often on tests or quizzes, we don't have access to Google, and we need to string together conversion factors that we do have access to. This is why this conversion factor is one of my favorites. I just find it very, very handy in a lot of different situations. Here we go. You can see at this point that now my milliliters cancel and I am in centimeters cubed. So I've converted out of what we call a derived unit for volume, and now I'm in a cubic unit for volume. At this point, I am more thinking, how do I get from centimeters to decimeters? Again, you can ask Google and get a straight conversion from centimeters to decimeters, but usually that is not a conversion we know off the top of our head. So I am first going to take centimeters to meters and then meters to decimeters. Again, I like to work these problems as if you were working them on a test and you don't have access to whatever conversion factor you would like. Here's my conversion factor going from centimeters to meters. There are 100 centimeters in 1 meter. However, centimeters cubed does not cancel with centimeters. So what I need to do is I need to cube the numerator, cube the denominator. Now I can cancel my centimeters cubed here, and I am left with meters cubed. I'm almost there, but not quite, because of course the problem wants me to go to decimeters cubed. So I have one more conversion factor to put in. Here it is. There are 10 decimeters in 1 meter. But I have to deal with my cubed. Meters cubed does not cancel with meters, so I need to cube my numerator, cube my denominator, and now my meters cubed cancels, and I'm left with decimeters cubed. So going back to the problem, let's make sure that everything has canceled except for the units we want, which are kilometers in the numerator and decimeters cubed in the denominator. So here's my kilometers in the numerator, and you can see that there is nothing else that has not canceled in the numerator, so that's good. And looking at all my denominator units, I can also see that I am left with decimeters cubed, so therefore this conversion is complete. Now I just need to put it in my calculator. So I'm going to take 9.80, I'm going to multiply by 1,609.3, then I'm going to divide by 1,000. Next, I'm going to divide by 3,785.4. Again, this is one that you can put in your calculator, but you don't have to. You're just multiplying by 1. Next, I need to take care of my cube. Now, here's where you need to be careful. Don't just multiply by 100, but you need to multiply by 100 cubed. And then for the last conversion factor, you need to divide by 10 cubed. It's easy with these long ones to forget that cube. So I get 3.7 times 10 to the negative 9th kilometers per decimeters cubed. Let's do one more problem. This problem reads, a 5.63 kilogram block of metal measures 0.53 meters by 1.45 meters by 1.15 meters. What is the density of this metal in pounds per gallon? And again, we get some conversion factors here. There are 3,785.4 milliliters in 1 gallon, and there are 28.35 grams in 1 ounce. It is very common in these more complex density problems to be given measurements. And when you are given measurements, what you need to do is you need to find the volume, in this case, of this block. So I am going to sketch out what this block might look like. Okay, so we just have a block of whatever metal this is. Let's put in our dimensions. I'm going to call this length the 0.53 meters. Then this one will be 1.45 meters. And finally, we have 1.15 meters. Now, it doesn't matter if you assign these all to width, height, or length. You can put them in whatever order you want. You can see clearly my block is not to scale here, but again, it doesn't matter. Just so you can visualize, this is a block. Here are all the dimensions. How do we calculate volume? Well, volume equals length times width times height, which we have all of these measurements. So I am going to plug in all of my dimensions and calculate my volume. So you can see right here, I've plugged in my dimensions that were given to me in the problem. Again, because we're multiplying everything, this is why it does not matter what order you put it in or how you assign length and width and height. However, it's not just the numbers here that we need to multiply, but we also need to make sure that we are multiplying our units. So our answer is 0.89 meters cubed. And this makes sense. We know that a length cubed is a volume, which is exactly what we want. Okay, this is great. We have a volume, but of course, density is not dependent just on volume. Density equals mass divided by volume. However, the problem did give us our mass, so we can plug in our mass from the problem, and we just calculated our volume right here, which means we can calculate the density. So let's plug those numbers in. So here is the calculation for density. Again, I took my 5.63 kilograms just from the problem, and the 0.89 meters cubed was what I calculated over here. This gives 6.4 kilograms per meters cubed. So this is fantastic. We do have a density, which is what the problem asked for. What is the density? But we have a little bit more work to do because the problem wants the density in pounds per gallon. And right now we have it in kilograms per meters cubed. So this is a problem that is not only asking you to calculate the density, but then we must do dimensional analysis on these units to get it to what the problem asked for. So let's set up our dimensional analysis. Starting with the density that I calculated, 6.4 kilograms per meters cubed. Now I need to go from kilograms to pounds. So I'm going to take a look again at the conversion factors they gave me. The milliliters and gallons, this is going to help me when I'm converting my gallons to get to my denominator, but right now I'm focused on my numerator. So I'm going to take a look at this 28.35 grams in 1 ounce. This gives me the conversion factor from metric to imperial. Well, getting from kilograms to grams is not a problem. That's just a metric. Once I'm in ounces, how do I get to pounds? Well, that is just 16 ounces in 1 pound. So those are the conversion factors that I need to string together to go from kilograms to pounds. So let's do that. Here's my conversion factor to go from kilograms to grams. There are 1,000 grams in 1 kilogram. Always making sure that my units cancel. Next, we are using the conversion factor the problem gave us. There are 28.35 grams in 1 ounce. Grams are canceling this time. Now I am in ounces. I finally need to go to pounds. There are 16 ounces in 1 pound. So my ounces cancel, and now I am left with pounds, which is exactly what the problem wanted. Okay, great. The numerator is taken care of, but now we need to work with the denominator. So in the denominator, I have meters cubed, but I need to go to gallons. So in this case, I'm going from a cubic measure of volume to a derived unit of volume. I'm going to gallons. I'm also moving from metric to imperial. So let's take a look at this conversion factor right here. This will allow me to go from milliliters to gallons. So my next question is, how do I get from meters cubed to milliliters? Well, I know at some point I'm going to use my favorite conversion factor. Let me just write it down one more time. 1 centimeter cubed is equal to 1 milliliter. So if I can get my meters cubed to centimeters cubed, that will get me straight to milliliters. Then I can go from milliliters to gallons, which is what I want. Again, I'm going to have to string together several conversion factors. I'm going to start by taking my meters cubed to centimeters cubed. Here's my conversion factor from centimeters to meters. There are 100 centimeters in 1 meter. However, meters cubed does not cancel with meters, so I'm going to cube the numerator and cube the denominator. Now I can cancel my meters cubed, and I have converted into centimeters cubed. Time for my favorite conversion factor. This is going to take me from centimeters cubed to milliliters. Again, my centimeters cubed cancels. Now I am in milliliters. At this point, I can use the conversion factor that the problem gave me, 3,785.4 milliliters in 1 gallon. My milliliters cancel, and now I'm left with gallons, which is what the problem asked me for. Before putting it in my calculator, I'm just going to double check my units. So in the numerator, I want everything canceled except for pounds. So you can see pounds has not canceled. That's great. Okay, numerator looks good. In the denominator, I want everything canceled except for gallons. Yes, that is true right there. So my units are set. Let's just put these numbers in our calculator. So I'm going to take 6.4 and I'm going to multiply by 1,000. Then I'm going to divide by 28.35. Then I'm going to divide by 16. Now I have to be careful here, of course, because I'm not dividing by 100, but I'm dividing by 100 cubed. Again, you can put the multiplication by 1 in if you would like. And then finally, I'm going to multiply by 3,785.4. I get 0.053 pounds per gallon. This problem was a long one, but hopefully it helps see how you can bring different concepts together, not only in how to calculate density, but how to change the units of density as well.
Density is fantastic, isn't it? It's so useful and versatile. I really love density. And hopefully now you are more comfortable using density and converting density in whatever way you need. If you're interested in learning about some more conversions, you can check out these videos here. And thanks so much for watching.